Good morning, everyone. Am I audible? Good morning, everyone. Am I audible? Okay, okay,
Yes, ma'am.
okay. Where is Toss? Let me take out the notes. We had done till the pressures, right? The water pressure, fix and moment distribution we have done. Hmm? Moment distribution, these things we have done, I guess. This moment diagram we have drawn, right? Today, I think we have got the depth to be this much, and today we are going to do this step, which is the design of long wall. Yeah. Hmm. So today we are going to design the long wall here. Bending moment at the end support we have done. Direct tension in long wall and short wall we have calculated. Hmm. So today we are going to design the long wall. Now for the long wall, we know that our moment was how much? Our moment was 63 kilonewton meter. We had our tension to be 54 kilonewton. Okay, so the modified moment support. No, no, no. So this one. No, tally. Yes, hello. Oh. Okay, we were where design of long wall here m is equal to 63 kilonewton meter. Then T our tension was 54. This one the direct tension for long wall was 54. We had the moment 63. हेलो। हाँ। आप लोग बुलाएगा नहीं, वो लोग तुमको जिसका जिसका लेना है ना सर्टिफिकेट, तो उसको बुलाएगा फोन करके। वो मैंने कंट्रोलर से बात किया था, तो कंट्रोलर ने बोला कि वही दीपांजलि गारू जो है वो तुम लोग को एक एक करके बुलाएगा। एक एक मीन्स लाइक सपोज फॉर 1 डे 10 20 ऐसे टाइप का। डिपार्टमेंट लोग? कौन डिपार्टमेंट लोग? अरे हम लोग नहीं बुलाएगा रे सारा। एंड वैसे भी सर्टिफिकेट्स यू हैव टू कलेक्ट फ्रॉम दिस वन एडमिशन से ए ब्लॉक ग्राउंड फ्लोर। हाँ, उसको बोलो कि तुम्हारा अर्जेंट है, तुमको चाहिए, तो इसीलिए आज या कल जब दे तो जितना जल्दी हो सके, मतलब कल चाहिए हमको, लाइक दैट। और उसको मैसेज दो। हाँ ठीक है। Okay. Yeah. So at the support we had this one for the long wall, design of long wall we were doing. So moment we know we have already calculated. We have the tension, then we have modified moment at support. These things I think we have done over 60 modified moment was here 63. This one minus tx. The diagram is there not for tx. No. Hmm. 63 minus tx. T is nothing but the tension. Okay. Suppose suppose you have this one here, the long wall here, this side. Then we have at the center, this one is your tension here. Okay. So now the reinforcement, if we provide it here, I think we have done this. These things we have done. Yeah. So I thought I explained this thing in last class, I think. So this 63 minus Tx, yes, ma'am, up to AST required. Okay. Yeah, we have done this. Till the long wall area of steel required, we have done. Then once we have got that area of steel required, we can go again for the short wall. We have to calculate the same procedure. We have to calculate with the tension, etc. We are going to take, and then we are going to find out the area of steel. 58 point, yeah. So here you see this was the area of steel required for your longer wall, this much. Okay. Now from here, now from here, for the long wall, again at the center, this one at the center we have done or not. Okay. This was design of long wall here. The area still required at the supports we have seen. Now we'll see at the center of the long wall is how much moment at the center we have calculated it to be 58.5 kilonewton meter tension modify same procedure. Moment minus your this thing, the moment due to this tension tx, x distance was 100, so we have got 54 into this much. Okay, 100 mm it was. Okay, so ast for the moment is m by sigma st into j into d. We will get this much. Moment was 58, only the moment is going to change here. Rest all sigma st j t, everything is same here. For the tension this much. Now the area of steel provided, total area of steel provided, we can calculate. Total ast was this ast for tension at the center, and this one for moment the area. area of steel this much, for tension it is this much, for moment, for tension at the center. So total area of steel required is this much. Now the area of steel provided will be how much? The area of the bars divided by the spacing if we do. So we will get the area of, see huh, total AST if we got this much, if we provide, suppose if now if we provide here, now if we provide 20 dia bars center to center, center bars center to center, then our AST if we have provided this much 20 dia bars and center to center spacing, okay, of this much 120 or 130 whatever you want to give. So then into 1000 we will get our area of steel provided. So provided is how much? Also one more thing, we must provide, always provide minimum area of steel. Minimum area of steel should be equal to 0.24, where it is percent, 0.24% on liquid phase. Okay, so we have to provide this much. Area of minimum should be area of steel 20.24% on the liquid phase. So area of steel provided is this much. We have calculated after providing. So we have seen what our provided is greater to 618 and our total area of steel required was 2318. 2318. So this is greater, provided is greater than the required one. So our design for the longer wall at the center also, reinforcement which we are providing is also safe. Okay, so after that distribution of steel we can do distribution of steel. If we see distribution of steel, minimum area of reinforcement for distribution bars is 0.24, we know, I just told you now. And then D is our 300, it was 300. So half of 300, how much we got? If we calculate the reinforcement is divided equally on both the sides. Okay, if the distribution bars are divided equally on both the faces, liquid phase as well as your outer phase, liquid phase is nothing but the liquids are acting here, and liquid waters are on this phase. So this is liquid phase, and this outer portion, this one is your outer phase. Okay, and this is a liquid phase. This portion is a liquid phase. So on this side half we are providing the distribution steels, and here also distribution steel 150 square, 150 square. So the for one phase our this one will be how much? Our D 150 square. Okay, now for one zone our AST required will be how much? This will be this one. Minimum was our 0.24%. So 0.24% into B into D. D is per meter. So 1000, and we have this one 150. 150 because two zones are there. Now this is your liquid phase. This side is your outer phase. So on the liquid phase we have how much? On the liquid phase we have this one area still required 150 will give on the inner face and 150 will give on the outer face, the distribution still. So we will have how much? This is 0.24% distribution should be there. So 0.24% of B into D, that means this much area of steel is required for both the phases separately. Okay, AST for one zone is, that means this much area of steel is required for the this zone as well as this zone. Okay. Okay. 1 minute. Okay, so we have how much here? Area of steel required is this much. Now we can provide the diameter of bars for the distribution steel, 10 mm dia at 210 mm spacing we are taking. So area of steel provided is how much now? The area of obviously the um, yeah. So, provided we will provide now for the distribution of steel, we will have how much 10 mm dia bars we are taking at 210 mm spacing. Area of steel provided will be this area of steel by the spacing into 1000 we'll get the provided area of steel which is greater than again area of steel required. This one was the 360 mm square was the area of steel required, distribution steel required, but our provided distribution steel is how much? This much. So it is okay. Now again same procedure which we have done for the longer wall, we have done what? We have calculated the reinforcements area of steel along the on the supports at the center, then distribution steel. So now for the shorter span, this one. For the shorter span, again we are going to do the same thing. That is at the supports, how much is the moment? We have 63. Then we have the tension. We have already calculated these things. This one here. For the shorter wall, our tension is how much? 81 kilonewton. Then we have the moment is same for both 63. 63 at the end supports. So for the shorter wall here, design along, this one is along, design along short wall. Now again here moment we know we have tension 81, modified moment at center is equal to m minus tx, same thing, x is at 100 mm distance, that means our reinforcement, and this is the tension here. The moment due to this tension is tension into this distance of the reinforcement from the tension zone. Okay, so that is how much the net moment is 63 minus this one 81 into the 100 mm. So 54.9 kilonewton meter is our modified moment. Now area of steel for moment is how much? This one same formula m by sigma st into j into d. M is this one. Now the net moment sigma st we know the j and we know the d depth 250. So again same thing for the tension. This one was the for the moment. Sorry. Okay, this one was for the moment, this one was for tension. Tension again we know the area of steel is T by sigma st. So T is our this much tension, sigma st is 130. So we got it to be this much. Total AST required is how much? Now this area of steel for moment and area of steel for tension, we add it and then we get this much. Now we can, once we know the total area of steel, we can find out the area of steel provided. If we provide, assuming 20 mm, taking 20 mm dia bars at 120 mm square spacing, we have how much area of steel provided will be id square by 4 by spacing. Spacing we have taken it to be 120 mm. So this much is our area of steel provided. What was our area of steel required? 2585, and this is 2618. So obviously again our steel provided, if sometimes your area of steel provided, if area of steel provided is this is less than your area of steel required, then what happens? If your this area of steel provided is less, what we are going to do, we are going to increase this diameter of the bars, or this spacing, we have to change the spacing. Okay, but now for now we have got what our area of steel provided is greater than the area of steel required, therefore it is okay. Okay, so now we have got this for the supports. Now area of steel required at the center, we'll see. At the center, we have moment is this much, we have the K is this much. Sorry. Now again, for again modified moment, we'll see M minus dx, same thing. Then this is same area of steel, area for moment you can calculate again, same. For tension again it is same. Oh, Ram. Hello? কেনেকে যাব? মই ক্লাছে লৈ আছিলো, এক মিনিট মই ছাৰকো কৈ দিওঁ। অৰ্ণৱ ছাৰ ন? ঠিক আছে মই কোৱা। অ' গড, মই ক্লাছ খতম হ'ব আৰু এতিয়া আহি আছো। আহি আছো। এ ৰাম, আহি আছো আহি আছো। উম। So these things, area still we are having now a meeting actually, but I was thinking I'll complete it. It's calling whatever. So I'll cut it short. So at the center also same thing. Then again area still same procedure. Same procedure again. Then we have the distribution of steel again. Same thing, area of steel, distribution. Okay, so again you find out the provided and the required one, whether it is okay or not. If it's not so, then again change the diameter and the spacing, and then you find out the area of steel. Okay, this is done. For the short bar also, this one, for the short bar also, we have calculated the area of steel at the supports and area of the steel at the center, and the distribution steels also we have calculated. Okay, now next one was our what? Next one was, or this was for the continuous frame. Now the bottom portion, which was 1 meter for the our cantilever action, that is to be done now, calculated, because this portions whatever we have done, the reinforcements etc., these were for what, for the continuous frame action we have calculated. Now the bottom portion was 1 meter for the cantilever action. Let me see one thing. I think I will stop it here. Everybody's, I'm getting calls for. Okay, please give me your attendance. I'll cut it for next class. Will end. I think our classes are extended for the this thing na, till 20 January we are having classes. So we are having lot of time now. So we can go slow also, no problem. And also we are asked to reschedule the classes, but I thought I'll take the class and finish. Please give me your attendance. Section A, na? Roll number 1. Hello?
Present, ma'am. Roll number 1.
Okay, 4. 4, 5, 6, 7,
Present, ma'am. Number 6.
8, 9, 10, 11, 12,
Present, ma'am. 0, 1, 2.
14,
Present, ma'am.
15, 15, 16, 17, 18,
Yes, ma'am. 18.
18, 17, okay, 20,
Present, ma'am. 20.
19, 19, 20, 21, 21, 22, 23,
Present, ma'am. 23.
24, 25, 26, 27, 29, 30,
Present,
30,
miss. 30.
31, 32, 34, 36, 37, 38, 39,
Present,
40,
miss. 39.
42, 43,
43
40,
present, ma'am.
45, 48, 49,
49 present, ma'am.
50, 50, 51,
51
52,
present.
52, 54, 57,
Yes, ma'am. 57 present.
58, 59, 60, 61,
Present, ma'am. 61.
62,
Ma'am,
63.
present 61.
Yes, ma'am.
63,
Okay.
Yes, ma'am. 63.
60, 99,
Yes, ma'am, 99.
101, 104,
Present ma'am 104.
okay, 106, 108,
108. 108 present, ma'am.
109,
109.
109, 111, 113, 114, 118,
118.
120, 124, 133,
Yes,
134,
ma'am. 133.
134 present, ma'am. 134.
okay,
134
136,
present ma'am.
143, 143, 144, 145, 149, 151. Hello? Oh, class. না এতিয়া মোৰ হৈ গ'ল মই ৰাখি আছো মই এটেনডেন্স ললো হৈ গ'ল ইয়া ওলাই আছো ছাৰ এতিয়া গ'ল নেকি অ' গড বিষ্ণুভাই কৈ আছিলে মই যাওঁ এইফালৰ পৰা কৈ আছিলে আৰু ছাৰ ইয়াতেও আছে ছাৰ ইয়াতে গ'ল নেকি অ' গড মই কোৱাও নাই মই পাহৰি গ'লো ফোন কৰিব মই আহি আছো Okay, we'll continue in the next class. Okay.
Ma'am,
And
19 present.
for the attendance also, after the second half, I'll give in the WhatsApp group also. Okay, how many are absent and all, and if somebody is present or missed out, you inform me. Okay. Okay. Thank you.